Hey, what's up guys, this is Krishna here. Welcome to this exciting tutorial on spinner fireworks. I'm using Houdini 20.0.506 and I'm going to render using Redshift. Now, it is my assumption that you know the basics and the fundamentals of how to use Houdini. Okay, let's jump straight into it. Let's create a geometry and dive inside and drop in a circle. Okay, and I'm gonna choose YZ plane. Okay, and so let's just set this up here, and let's use the uniform scale of 0.5 for now and divisions of 50. That's it. And let's create a null and call this out. Okay, so that's our basic circle. Okay, and what I also want to do is make it open arc. Okay, good. So if you want to check the number of points here, there they are. Okay, all right, cool. I'm gonna call this circle. Okay, and I'm gonna just keep it on the side, and let's create another geometry here, and this is where we're gonna do the particle source. Okay, well, set up the particle source. All right, let's jump in. Here, let me bring the circle that we created. There it is. Okay, and into this object. Okay, cool. Now we've got that set up. So all we're going to do is get a sphere here. Okay, and copy 2 points because I want to start from base and then we will build on that. Okay, so geometry required a copy and the target points are here. Okay, so basically it looks like a donut. Let me put in an attribute randomize because then we can specify our p-scale here. Okay, so that'll be a custom ramp and I want to fit the values between the two. Okay, that looks okay to me. Right now I'm also gonna drop the end frame to 144 because we don't need any more than that, and the frame rate is 24 frames per second. Okay, apply that. At the moment, if I just enable this time and play this, nothing's going to happen. It is not spinning. Spinning is one of the most important things for a spinner, I guess. So we need to get that sorted. So what I'm going to do is I'm going to put in a transform here, and I want to show you something. So fine, now put in here, and I'll put rotate in the X direction. Right, there you go. You see how it's rotating? Okay, and if I were to rotate it in the Y axis, it's just going to do that instead. All right, we don't want that. So I'm going to put in a 20 here, and you see when I play this, nothing's going on. Obviously it moved, but you need to constantly move this. Instead of putting in a frame, let's say here, and rotate it like this, I have a better solution. What I'm going to do is I'm going to put in a solver. Okay, now in solver, what happens is it looks at the previous frame and keeps incrementing the rotation value. So if I put in 20 here, it only does it once in one frame and that's it. It just stays as it is. But if I now cut this and paste it inside of the solver, guess what will happen? This will now start rotating. You see that? That's it. Basically our rotation done. Okay, cool. Now I got that sorted. Let me put in a null here and then out. Okay, we got our source set up now. Okay, now I'm going to come back to that because there are some issues here at the moment. But anyway, let's create another geo folder here and we'll call this sim. Okay, simulation, and let's dive in and let's do an object merge and let's grab that particle source. Okay, by the way, we're creating spheres so that the particles can emit from a surface. Okay, that's all. All right, I'm just going to drop in a pop network here and I'm going to run this and see how that goes, and I'm going to template this guy here. Okay, So you can see that it is rotating, but the particles are just stuck. Let me get a display here and increase the particle size. Okay, so there you go. You can see now it is obviously coming up. The particles are being generated, but they're just stuck in place, and that just means one thing. It means there's no velocity, because if I go inside of here, you go into attributes, you see use inherited velocity. We don't have a velocity at the moment. That's why it's not doing anything. If I were to add to inherited velocity, so I'm adding a variation of 111, you'll see that it will go away, but that's not very good. That's not what we want at the moment. So first of all, we need to create a velocity out of here. Okay, so let me drop in a polyframe. Okay, and what does a polyframe node do? Okay, so if I now look at this guy, this is just a circle, and if I click on this normal here, I don't have a normal. I'm generating normal here. Okay, as you can see, the normal is now generated. However, it's facing that way, which is not what we want. We want it along the curve. Okay, so I'm going to uncheck that. I'm going to change the tangent name to N. Suddenly we have this kind of normal pattern, which is what we want, because the spinner is going to spin that way or this way. I don't know yet, but that's the way we want it, right? And we need to transfer this normal to velocity. At the moment, we don't have velocity. If you look at click on the eye, I have a normal and a point information, but no velocity. Okay, so let's create a point velocity and drop that in. And I'm going to change the initialization from attribute, and it automatically chooses N, which is our normal. Okay, now I'm going to get rid of that. I'm going to choose this I again, and I'm going to click on this V, because now we have velocity. Okay, there it is. If you want to get rid of it, just push this icon or right click it and untick this box here. Okay, whatever. So we have velocity now. We don't have velocity here though. You know, we have it here, but not here. So what we're going to do is we're going to transfer that velocity across. Attribute transfer. And I'm going to put that in there, and I'm going to select velocity. Now, if I click on this, there you go. The velocity has been transferred. So without it, with it. Okay. So what I'm also going to do is I'm just going to add a little bit of noise, curl noise. That's too much. So maybe 0.1. Okay, just a little bit. That's all. And let's now go and check the sim to see what goes. You see now it's starting to move where we want it to move. That looks decent enough, I guess. But that's the idea behind it. All right, so now let's actually go ahead and increase the scale. 10 maybe. Okay. And let's see what happens. You see, that looks a lot better. So now we've got the spin going. What we want to do is we want the spin to start slowly and then increase over time, and then reduce over time and then stop. But at the same time, not only we need to increase this rotational speed, we also don't want to have all of these sources available at the same time. So what we're going to do is we're going to tie rotation speed to the number of particles that are generated. Okay, I'll show you what I mean. Okay, let's go back into particle source for now. So what I'm going to do is I'm going to put in a delete here. Okay, and this guy, not the branch where we are generating velocity. Okay, leave that alone. Just below that here. Okay, so what I'm going to do is I'm going to choose points. Okay, I've got the points here. I'm going to delete by expression, and I'm going to say random at pt_num is greater than 0.5, and this means that 50% of the time the points are going to be deleted. Okay, now if I change that number, the lower the number, the less number of points we have. As I mentioned before, I'm going to tie that number to the speed. Okay, so how do I do that? Let's put in a null here, and we're going to call this controls, and let's change the color to black and change the shape to that. And I'm going to just disable these. And I'm going to add three things here. The first one is a float. Second one is another float. And then third one is an integer. The first one, I'm going to say rot speed or rotation speed. Okay. And then the next one is rot sp and mz normalized. Okay. Rotation speed normalized. And the reason why we have normalized rotation speed is because we may be using this from 0 to 1000, say for an example, but we want a normalized value as well. So in some places we are going to use that. Okay, that's why I want this controls to be the one place where we can change all these, so you know everything just propagates across to every level. The next one is, I'm going to call this peak FR. This is called a peak frame. Okay, and I'll explain what that is. And this is going to be an integer, okay, because it's a frame number. All right, I've got all three here now. Okay, so what I'm going to do is, first of all, at the start, this is going to be 0. Press and hold Alt and click on that, which will insert a keyframe. Okay, I'm going to disable the sim for now. At 24, I want it to go up to 20. At 48, I want to change this to 30. At 96, I want to keep it at 30. And at 108, I want to drop this down to 0. We know that the maximum is 30. Let me just copy this guy. Copy, paste it here. I'm going to say fit this guy between 0 and 30 to 0 and 1. That way, when that goes from 0 to 30, this will go from 0 to 1. And the peak frame, the frame where the highest speed is happening. So let's choose 96 here. Okay, let's dive in. So I'm going to tie that up. Okay, let me get this guy here. So I have two sides. I'm going to say we want the normalized speed here. Okay, because this number, this random number, is going to be between 0 and 1. Okay, so I'm just going to select that, and I'm going to paste relative references. Now what is going to happen is when that speed increases, you're going to get more points here. Okay, watch that. And if I enable this guy here, so you can see when the speed is going up, the number of points are building up, and then when the speed goes down, you'll start to lose the points, and that is exactly what we want. So let's just go and make sure that our velocity is still transferring. Okay, and this is why I put this peak frame here. Okay, do you know why this is happening? It's because the solver will take the first frame and then calculate inside. Okay, and the first frame, there's nothing there. But if I put in a time shift here and copy this peak frame, delete this guy and put that peak frame in here. Okay, now I've got all of my spheres shown up. Okay, now you see what will happen is that thing. What we want with all of the things that we did up here to reduce the number of points and then bring it up when the speed goes up has disappeared now. That's because this guy has a timesheet enabled. We need to bring this deleted number of spheres back in. Okay, so the best way to do that is by putting in a point wrangle. We're going to connect the first one to copy the points here. Okay, and then the second one to the solver. I have a template set up already. It's called position transfer. So all I'm going to do is transfer that position. So what does that mean? The current position then will be the position that is coming in the second input, which is number 1. So just type in point, open brackets 1 comma, you're looking for the attribute P, and you're going to match it to the point number. So now what will happen is this will start to rotate like that. Okay, and that is exactly what we want. So I'm just going to put in here position transfer. Now every time you change your peak frame, this will automatically change. Okay, let's make sure the velocity comes up. I've got the velocity checked here, but there's nothing showing up because there's just no geometry here. But now you see, there it is. And now let's go and check the sim and see what that looks like. Let me enable that. Oh yeah, there it is. If you notice that at the start, of the frame, these particles are just being thrown apart. Okay, now that's okay, but we don't want that for the spinner because we want it to start gradually and then increase the speed over time and then reduce the speed over time as well. Now again, we're going to go ahead and use the controls. Okay, now if I dive into PopNet here, I have this inherited velocity. So what I'm going to do is I'm going to copy this normalized speed here. Okay, and I'm going to paste this guy in here. Okay, now let's run this. You see, there you go. That's looking a lot better. So next thing I want to focus on is how far these guys are traveling. Okay, so what I'm going to do is I'm going to go to birth. I'm going to keep this at 0.2 and 0.4. Let me try that. I think that's decent. So if I look at that, okay, that's good. So what I also want to do, get this pop. So now we've got this guy going. That looks pretty good. But at the start, you can see there are 1,088 points here. Okay, well, it's okay, but I want to start the number of points gradually as well as and connected to the speed. Okay, so how can we do that? So let's go back to controls. Let's copy this normalized speed, and you see this constant birth rate. So I'm going to go ahead and paste this relative expression here, and I'm going to say, okay, multiply that by 5,000. So what's going to happen is when the speed is at its maximum, the maximum number of particles or birth rate is 5,000 because your normalized speed would be 1 at that time. But the benefit of this is that when the speed is low, it's not going to generate that many points. See, now we've got how many points do we have here? So 228. Earlier, at this point, even at 24th frame, we had like 1,000 points or whatever. See, so now that's gradually starting up, and it's also going to end gradually as well. So when it drops out, you see, it just drops out wonderfully. Okay, cool. So I'm going to drop in a spark trail. Okay, so we can visualize it better. All right, I'm just going to enable that. I'm going to let it run. You can see now it looks wonderful. Okay, let me set up a camera here. I'm going to reset these. I'll be 14 maybe. That guy will be 0, and this guy will be 0 as well. Okay, so bang on in the middle here. Okay, so now you can see how it is just coming into fruition here. I'm gonna just to the side, move to the side here. You can see this is going to be like a straight line. All right, I'm going to go ahead and add to inherited velocity here. Okay, again, I'm going to copy this normalized speed. I'm going to paste that guy in the variance here. Again, the variance, I want high variance when it is slow, and then when the speed picks up, I want the variance to go down, meaning I want it to go all over the place when it's slower, but when it's faster, I want it to stick to it. However, we will introduce a little bit of variance at a minimum. I'll show you what I mean. Okay, so right now your variance is 0. Okay, now if I disable this guy, if I go forward at at 48, we've got a variance of 1. What I'm going to do is I'm actually going to copy X value and paste it into Y and Z. Okay, so it's all the same. All right, so what I want to do is want to put in a 1 minus that normalized speed, meaning when it is slow, it's got a higher variance. When it reaches its full speed, the variance is no longer valid, meaning it's 0. Okay, but at the same time, we don't want that. What we want then is we want to put in an expression called max of the two. You want a maximum of 1 minus this guy or 0.2. Whichever is the maximum of the two, that will always be there. Okay, meaning the minimum it's going to get to is 0.2. We can also put in a multiplier here. Let's say 4 multiplied by. Okay, That way you've got a minimum variance of 0.2. Actually, I want to put this multiplier inside here. Okay, so 4 multiplied by, so it's 4 is the maximum variance you're going to get. Okay, let me enable the sim here. Okay, let's run it now. See, I think that looks pretty cool. Okay, the next thing is oh, actually I wanted to show you this. Let me go back to here. Now, there's not a lot of variation here, okay? But at the start, you can see there is a lot more going on. The velocity is being varied very high here, and that's why it's moving off there. Now, if I were to say I want the minimum to be, let's say, 1 here, okay? So it will always be between 4 and 1, okay? It won't go below that, all right? So let's try if that works any better. So you can see it's no longer flat, okay? By the way, this is a vertical spinner, okay? If you want to have, obviously, ground spinner, you just put it on the ZX plane. I'm guessing everything else will follow except for this rotation here, okay? And that rotation needs to change from X to Y here, okay? So that way, now you'll see that this guy will go that way. So let me just get this one. So there you go. You can see here that it's going okay, going very well, but there's something missing, which is the gravity. So let's put in a gravity force here, okay, and let's check it out. There you go. That looks much better. The next thing I want to do is go back to the birth rate and increase this guy to 10,000. And let's see how that looks. It looks pretty good too. One last thing, or two more things, I guess, is that I want to increase the substeps. So I'm going to put in 4 substeps for PopNet. And what I also want to do is in here within the solver, I want to increase the substeps for this one as well. Okay, let me play this now. So you can see that's looking a lot sweeter now. Let me get rid of these two. Let's try it again. See how that is just doing that. That is nice. I think there may be a problem here, by the way, and that could be because of this time blend. You see this guy is 100, but we have 144. I'm just gonna put in $RFEND here, meaning render frame end. Okay, so that way, if we change the frames later, it's gonna stick to it, right? So now, so that looks good as well. So you can see that it is going really fast, and that's why it's picking up those spots. Okay. And I also want to increase the substeps in the spark trail as well. So far, so good. I'm going to enable split. Let me just put it to 72 or whatever. Enable speed ramp. Okay. I'm going to leave it all at default. Nothing to change there. Shape. Positional noise. I'm just going to add 0.01 or even less. 0.005 because I don't want that much. Just very little. And then intensity is fine. Color is fine. However, I am going to add color over normalized age here, and also scale over, maybe not scale over normalized age. Nah, color is good. All right, I'm just going to leave it at color, okay, not scale. Okay, I think we are pretty good here now. I just brought the impulse activation to 0 because we don't need that, okay. What I do want to do though is see this jitter birth time and interpolate source. I want to change them, okay. So before I do that, I actually just want to get a, let's get a playbook here, okay. Playbook is done now. Let's have a look. Okay, so there you go. That's how it looks. All right, cool. So what I'm going to do is now I'm going to go ahead and add a negative birth time and a forward interpolating source. Okay, now I may actually choose to use a back interpolate source. Okay, so I've got both of the flipbooks running on either side here. On the left one is with the back interpolation set, and one on the right is with no interpolation set. Okay, so you can kind of tell the left hand side is a lot more organic, okay, compared to the right, but that's my feel. Anyway, I'm gonna add a grid here. Okay, so, and the circle. So I'm gonna ghost this guy. Okay, so you can see that the grid is on it. Now you can go ahead and put this up, whatever. Let's give it a shot. All right, so I'm gonna push this up to 5. Okay, I'm gonna leave everything as it is. Let's see if this is gonna work. Okay, and yeah, so this is what I was gonna say. So we have a little problem here. The reason why it doesn't work is because if I look at the particle source, when I'm transforming this, I'm rotating it with the pivot being the center. Okay, now if you were to move this up or down, you need to transform your pivot along with it. So I mean, the simplest way to do it is by putting in a centroid 0, d underscore x. You can copy this guy and paste it in y and change this to y, paste it in z, change this to z. Now you got a pivot translate of that one. Okay, now let's try and change this position to number 5. I'm gonna push that up there, and let's now check it out if this is going to work. Okay, so that is working. That way you can actually change the position at the start here. Basically what I wanted to do was I want to just put this up by 4, okay, because we're creating a grid. Okay, so I'm going to go ahead and get that, and we've got a grid. I'm going to increase the size to 50, let's say, and drop in a remesh. Okay, and I'll tell you why. It's just a simple trick. I don't need to do this, or you don't need to do this. I'm just going to go ahead and actually put in a volume extrude here, or extrude volume. Okay, and on the left hand side, I'm gonna call it out. Okay, so this guy is now ready for to get inside here. Let me go into the actual pop network and put in a merge after the pop solver and connect the static object. Okay, and let's drag and drop this into the subpath. A few things to watch out for. Okay, first let me play this. You can see that the particles are penetrating our grid. We have 4 subframes, but that doesn't look right. Okay, so generally the problem could be your collision itself is an issue. But before we get to that, I want to have a look at this merge. You see this relationship, left inputs affects right inputs. I want to change this to mutual, so both this and this gets affected mutually. Let me just change it around. So let's see if that made a difference. So that's still going through it. Let's try and fix the actual collision geometry. Let's see what we got. I'm going to uncheck the display geometry. I'm going to look for the volume collisions. You can see there's nothing really there in terms of collision. So let me increase this to 80 here. See, suddenly it's appearing. Okay, so your collision was a problem because it did not exist. And go back and display the geometry again, and let's run this guy again, and now nothing is passing through it. Okay, so that's the first one. All right, next thing I want to do is I'm going to go ahead and remesh this guy. Okay, so I've got plenty to play with, and I'm going to put in a mountain. Okay, let me see here. So that guy, so that looks good, and the amplitude to go up, but I want the element size to be 3. What I want is these particles to bounce off of this here. Let me connect that to there, connect there. Okay, that's looking good. And now I'm hoping our collision guide will, yeah, I think that's okay. Remember, if this was 30, which was default, that's how it's going to look like. That's no good. Okay, increase the uniform divisions responsibly, because this could actually slow your sim down significantly. Let's try that again. So nothing is penetrating. Okay. All right, that's good. So the next thing I want to do is go to this pop solver and go to collision behavior, and I want to color hits, and then I'll move it to hit. I just want to see what particles are being hit. Okay, there you go. So those particles in red are colliding. Okay. You can use this. You can actually use a collide group. Collided on the outside, meaning outside of the sim here to your spark trail. Like for an example, if I put, okay, so it's only working on the collided part here. You can see. So that's something if you want to use it, but I'm not gonna do that. All right. What I want to do is create a pattern here, which smooths out this region. And I want to do that because if you were to, not have a vertical spinner, if you have a ground spinner, you would want your ground to be flat down here, okay? Although I'm not using a horizontal ground spinner here, I'm just showing you that so you can use it if you want, okay? So I want to put in attribute mask from geometry, okay? And I'm going to bring in object merge, okay? And I'm going to bring this guy, reference geometry. And that is going to be our circle. Okay, I'm going to bring this fella, and I'm going to connect this guy here, and I'm going to say, okay, where's the mask? Let's have a look. You got to enable this guy, otherwise it won't work. Okay, so you see this guy's up there. Okay, now if I were to transform this fella slightly down, I've got this down here, and I've got the mask, and I'll enable. So I'm visualizing the mask, but I can't see anything at the moment. So let's see, -5 here. Okay, so now you can see something show up. Okay, obviously if you're going to adjust this guy, okay, the center, you may want to copy and paste this guy here, paste relative references, and then add a negative at the top. Okay, so we've got it right here. Okay, cool. Let me see, radius. Okay, so there it is. We've got an output mask. Okay, so what I'm going to do is I'm going to use it, plug it into the mountain, and in the mountain, and I'm going to say blend, and that will be user attribute, and that'll be our mask. Now obviously we've got it the other way around, so we're going to change the output here. Okay, so now the one in the middle does not have it. Okay, everywhere else there is. So I can actually just bring this up if I want. There you go, something like that. If I were to reduce this guy to 1, you can see here that you've got 2 spots. I don't want that. Okay, so what I'm going to do is I'm going to put in ends here. Okay, close rounded, so that way we will have this guy. So I'm just going to increase the radius here. Okay, and now if we go back to the sim here, you'll see that this guy is that guy showing up. You may need to increase the divisions again, so 128 maybe. Wait, where is it looking at? Grid out. Maybe I need to increase the mask here, so oops, 10, 25 maybe. Okay, you can see now it's showing up. Okay, I'm just going to enable this, and I'm going to get rid of that, and let's visualize it for a second. Okay, so I've got the sim set up here, okay, but you can see the camera itself is actually in the wrong position at the moment because we pushed the circle upwards. So I'm going to have to translate this guy up as well. I'm just going to do a flipbook and then come back. Okay, the flipbook is done now. Let's have a look. That looks pretty cool. But what I did not show you is this part here, or I could not get it on the camera, is this part here. Okay, so there are no penetrations. Okay, so as well, I wanted to create this so that it will bounce off of here. Okay, I'm going to go ahead and kill this mask. Okay, and also get rid of this blend. So now you will see that it'll bounce off of this uneven surfaces. You can see some of these are bouncing off of there. Okay, so I've got 93 frames done. So now you can see here, you can see that's bouncing off of the ground here. Okay, so the next part is we're going to go ahead and do the rendering using Redshift. Okay, if you don't have Redshift, or if you don't want to do it, it's fine. You can end it here. Okay. Alright, so let's move on to rendering now. Okay, first of all, let me go to out context here, go to Redshift and drop Redshift node, and I'm going to drag and drop that here, and I'm going to call this spinner. Okay, and I also want to drop an RS dome light here. Okay, and I'm going to choose a night HDR. This is available from Polyhaven. Okay, so next thing is I want to get to a shot where I feel comfortable rendering. Okay, that looks pretty good. By the way, I don't know why this is throwing an error every time nowadays. I mean, this is actually, what version is this? 3.5.2.1. So it's throwing an error recently. It never did before, but when you render it, it's actually fine. So I don't know what's going on with that. But let me disable those. Let's go ahead to the material and let's drop in an RS material builder. Okay, and I'm going to call this sparks. I'm also going to go ahead and kill all these guys, and I'm going to move this guy to the left because I want to create another geometry container, and I'm going to call this render sparks. I'll color this red so we know. Okay, let's get the sparks. Okay, and sparks will be from our, okay, so we haven't set that up. Okay, so I'll put in a null here and out. Okay, if you want, you can select that, copy that, but Control C, and then go in here and Control V. There you go, and into this object. So I'm just going to keep it at 72. Let's put in a material, and we're going to drop this guy over here, and then we'll put in a null and then call this out. Okay, so inside of sparks I'm going to get rid of this, and then we put in RS incandescent. Okay, because we want the sparks to emit light. Okay, so I'm going to connect the out color to surface and change the intensity multiplier to 20. And remember, the sparks, if I go to sim here, the spark trail has color. Okay, this is already set up, so I want to make use of that in here. So I'm going to drop in a point, RS point attribute, connect the out color to color, and the CD is what we want. It's already set up by default. Let's give it a shot. I'm going to hit render. You can tell something's happening. Okay, but not a great deal is going on here. First of all, let me get rid of the background here. Okay, I want to go ahead and go to the Redshift OBJ and go to strands and render object as strands. Immediately, you see, this is a significant difference. Okay, and I want to change this to cylinder because it looks much better. And now your default scale is 0.01. Okay, and the global scale multiplier is 1. But we haven't really set up a proper p-scale for the output, you know. So what I'm going to do is I'm going to go into render sparks here, and before that I'm going to say a pointer angle. I'm going to put in a pointer angle here. I'm going to say at p-scale is equal to at age. Okay, and then I'll fit the p-scale is equal to fit at p-scale, comma 0.25, comma 0.75, comma 0.008, comma 0.001. And let me explain what this is. Okay, so basically I'm saying p-scale will equal to its age. Okay, but age is way too much. Okay, we'll get enormous cylinders here. So then I'm saying that fit the current p-scale that is currently between 0.25 and 0.75 to 0.008, and 0.001. Normally this will be 0.001 and this will be 0.008, or minimum maximum, you know. But I'm doing the opposite way, because when the age is low or it's newly born, I want it to be bigger. When it gets older, I want it to get thinner or smaller. That's the idea. Let's see if that works first of all. Okay, first thing I'm going to do is I'm going to render this and I'm going to take a screenshot. Okay, so there it is. Got a screenshot here. Okay, let's adjust these and let's see if I adjust this to 001. You can see that's gone down, and if I were to increase this to 8 or even 8, you see towards the end it's become bigger. Okay, and that's what I want, the opposite of that. All right. Okay, see where I've said p scale is equal to age, and then I'm fitting the p scale between these values. But instead of this line, if you just put at age right here, I don't even need this line. Okay, I just want to adjust this to 0.004 instead. Okay, so there you go. Okay, that looks good to me. If you notice, at the moment this does not have motion blur. Okay, a couple of places where you want to enable that is number one in Redshift, under settings, you want to enable the mesh deformations blur. Number two is go to out in here under Redshift, click on advanced, motion blur, enable deformation and instances particle blur. And now you'll see, let me just take a screenshot of that and press that. See, difference, big difference, that versus that. Okay, so let's move on. Let's make this even better. Let's add a bloom and let's add flare, but it's too much of flare, so I'm just going to drop this down to 0.01, the flare intensity. And bloom, I want to bring the threshold down to 10, so that way more of it gets brightened up. I'm going to add a LUT, but before applying LUT, you need to apply color management. Okay, and then I'm going to choose 100. All right, cool. So we've only rendered sparks at the moment. Okay, so I'm going to go ahead and include the grid, and also I'm going to add a backdrop after that. Let's do those. Okay, let's create another geometry. Actually, let me just press Alt and hold, drag and drop this. That's it. I'm just going to call this render grid and get rid of that, and I'm going to call out the actual grid here. Okay, and this guy, I'm going to copy this and call it grid, and I'm going to drag and drop it in here. Get rid of that, get rid of that. RS standard material, connect that here. Okay, cool. But if you copied from render sparks, please get rid of that. Okay, otherwise it won't work. And I also want to add Redshift objects. I want to get rid of the candidate objects and force objects, render asterisk. So anything with render flag will get rendered. Okay, so I'm going to click render. So you can see here it's showing up. That doesn't look that great, so I'm going to go ahead and go to material, go to grid, and drop this color to kind of a darkish color. The roughness at 0.1 or 0.05 maybe. So next thing I want to add is actually just create another geo container here, but I'm going to call this RNDR backdrop. Okay, bdraw, and I'm going to put in a grid here. Okay, and this grid I want to ghost the other objects so I can see. Let me see. Okay, and this guy is going to be XY plane, no, YZ plane, and I'm going to push this guy up, and let me look at the camera. Okay, that looks good. I also want to push the center out towards the end here. 40, oops, 30, 50 maybe, 60. I just want to cover this entire thing. Okay, so I'm going to put in another material here and a null and call it out, and I'm going to select the same grid material for the backdrop as well. Okay, color this red. We got that now, so let's go ahead and render this guy. Okay, so with the grid, I'm going to go ahead and push this number down. Okay, so it looks darker, maybe. Okay, good. I think that is okay. We just need to adjust the camera a lot more now. Okay, first of all, I want the focal length to be 90. Okay, so it's kind of closer, but at the same time, I'm going to pull this outwards. So let's say 50 maybe. So there you go. That looks a lot better. I also want to include optical and enable bokeh. Okay, so now there's a little bit of bokeh. And if you click on this icon here to focus, and you click on the element you want to focus, it's going to give you the sampling distance. Okay, I'm going to just alt click on here. So we've got that. And I also want to reduce the f-stop. So the bokeh is visibly clearer than what we're trying to achieve here. Okay. All right, cool. So in the grid, I'm just going to increase this a little bit. 75 maybe. Yeah, I think that's okay. But I also want to move this, turn this around by 310. And kind of the light comes off of there. I don't know. I'm not sure if I like the way these things are. So I'm going to go ahead and reduce the intensity of this guy. So I'm just going to push this element size to 4. So it's not too big. Okay. Let's go back to 72. It's going to have to sim again because we changed the grid. Okay, let me render it again. I think that looks slightly better because I could see these reflections here. So what I also want to do is animate the camera at the end. Okay. But I won't do this now. Increase the number of particles in the sim and we'll take it from there. So I'm going to make this 50,000. Okay. So now if I go to 72, okay, you can see there's a lot more. Okay, so that looks good. I just don't like how small it is. Okay, so at 48, we've got 30. So I'm going to push it up to 40 here and kill that guy. And push it up to 40. And remember, when you change that number, the maximum number, you need to change this guy as well. Okay. Okay, so now if I go to 72, that should go outwards a lot more. Now, if you're happy with the rotation speed, but want more off of this, you can directly change the simulation itself. Okay, so I think at the moment, this is still not picking up that much of speed. Okay, I mean, primarily because of gravity. Okay, so what I'm going to do is I'm going to go ahead and kill that. I'm going to multiply this by, let's say, 4 multiplied by that. Now, see, that should go up like crazy. Okay, that's too much. How about there? Okay, that looks okay to me. Let's see how that looks. Yeah, I think that looks all right. Maybe too much. I'm going to split the difference. Okay. So what I'm going to do is I'm going to go ahead and put a 1.5 here. I think that's us pretty much. Nah, 2 is good. 2 is good. 2 is good. Okay. I'm going to go back to 2 again. Okay, so I think the last thing to do is the animation itself. Okay. Camera animation. So I'm going to cache the whole sim here. At 72, I want to be right there where I am. But at 24, I want to be at distance of 15. 120, let's say. So even 144 for that matter. I just want to go back a little bit. 52. Okay, that's fine. So basically the last bit, you're just gonna do a very subtle movement. Okay, so let's do a flipbook on this now and I'll come back. Okay, the flipbook is done now. Let's have a look. Yeah, I think that looks pretty cool. We want to try and render at frame number 24 because your sampling values will be different. Okay, so let's go ahead and click on render. Okay, so as you can see, obviously out of focus now. So I'm going to go ahead and click on that and click on this again. Sometimes it doesn't work, so you may need to click on a few locations. Okay, so it's 14.8, so I'm going to go ahead and Alt click on that. I set a keyframe for that, okay? And at 48, we want to double check it still works. Yeah, that looks pretty good. At 120, there's nothing there, so 96. Yeah, that still looks pretty good. At frame number 1, I'm going to put in 10 here, okay? Okay, we're ready to do a test render, okay? For test renders, usually what I do is I change the camera, first of all, to 1080, and I'm going to override it to half, okay? And go to Redshift, and in sampling, I'm going to change the threshold to 0.05, but still leave it at automatic sampling. Okay, and I think that's about it. And in system, I want to change the bucket size to 256. Okay, I'm going to go ahead and render the frames, and I'll come back. Okay, so the rendering is done now. Let's have a look at it. Okay, I think that looks pretty cool. The only thing I want to change here is the starting speed, okay? So that looks to me like it's very fast, okay? So from 1 to 24 seems a little bit too fast for me, okay? So what I'm going to do is I'm going to go ahead and get that changed, and that's about it really. Let's go to particle source here. And no, actually the controls. Okay, so on the 24th frame, it's sitting at 20, okay? I'm going to disable this sum for a second, and I'm going to change this to 10. So it starts up slowly, and then at 48, it's at full speed of 40. Okay, let's check it out. Okay, so as you can see, it's starting very slowly. That's good. However, you can see particles only come into play on the 15th frame. So let's do something about that. Let's go into delete here. This is where the problem is really. So you can see it's only the 13th frame where it really starts coming into play. So let me add a +123 inside of the random. Usually you add this as a seed value, so you can change that number to get a different result. Okay, so now let's see here, it's coming into play at number 7. Okay, frame number 7 instead of 14, I think. So that's a lot better. So that's all I wanted to do, and let's reset this and let's check it out again. Yeah, I think that is okay. I'm just gonna do a flipbook here and I'll come back. Okay, so the flipbook's finished, and let's check it out. I think I like that a lot more. You can also see here bouncing off. You can see this line here. This is bouncing off the surface. Okay, so that starts slowly and ramps up, and then bam, done. Okay, so that's the end of the tutorial. So hopefully this was useful to you. If you liked it, if you learned something, please give me a like, thumbs up, as well as comment, share, and I may post this file on Gumroad. Please check it out. It might be in the description. Okay, all right, until next time, cheers, bye-bye.